Analyze the continuity of the function f at x equals x when x is less than 0, x squared when 0 is less than or equal to x, which is less than or equal to 1, and x cubed plus 1 when x is greater than 1. So we have this piecewise function here, and we want to think about, is this function continuous? Well, what happens when x is 0, first of all? If I wanted to think about when x is 0, I can think about the continuity of that. So what's happening from negative infinity to 0? And then what is happening between 0 and 1? And what is happening between 1 to infinity? So that's what I want to think about. So I want to think about what is happening at 0. That's our first sort of critical point right there. So let's analyze the continuity at x is equal to 0. So what is the limit as x approaches 0 from the left-hand side? Well, if we're approaching it from the left-hand side, we want to use that first function, which is x. So it's going to be the limit of x, and if I throw 0 in for x, it's going to approach 0. What happens as I approach 0 from the right-hand side? If I'm approaching 0 from the right-hand side, then it's going to be x squared. And if I put 0, substitute 0 in for x, I'm also going to get 0. And this is actually the same as the value at f at 0, because f at 0 is going to be 0 squared, which is 0. So we have the limit as x approaches 0 from the left side equal to the limit as x approaches 0 from the right side, and it equals the limit, equals the value of the function at that point. So we can say it's continuous at the point x equals 0. Now let's find out what happens between 0 and 1 and 1 and infinity. So same thing, we're going to take a look at what happens as x approaches 1 from the left-hand side, what happens as x approaches 1 from the right-hand side, and what happens when I substitute 1 into this function. If I'm approaching 1 from the left-hand side, I'm using this second function, which is x squared. And if I substitute 1 in here, I'm going to get 1. If I am looking at the value of the function or the limit of the function as x approaches 1 from the right-hand side, I have to use this bottom function, which is x cubed plus 1. And if I substitute 1 in there, 1 cubed is 1, and 1 plus 1 is 2. And if I look at what is the value of the function, I want to use, because it's less than or equal to 1, I want to use my second function. So I'm substituting 1 into x squared, which is 1. So if I analyze what we have here, the limit as it approaches from the left-hand side doesn't equal the limit as it approaches the right-hand side. And so the limit doesn't exist. And as soon as that limit doesn't exist, then we're going to have a discontinuity there. And the value of the function doesn't match here. And so because we are jumping from one y value up to a different y value, then we're going to have a jump discontinuity because I'm jumping from one y value to another y value. So it's discontinuous and it's a jump discontinuity.